Electric vehicles are often hailed as the vanguard of sustainable transportation, promising a future free from the environmental burdens of fossil fuels. But is the reality as green as it seems? Today, we embark on an in-depth exploration of the entire life cycle of electric cars to uncover the nuanced truth behind their environmental impact. Electric vehicles have traversed a remarkable journey from their inception in the 19th century to their resurgence in the 21st century. The convergence of technological advancements, heightened environmental awareness, and supportive policies has propelled EVs into the mainstream. By 2024, global EV sales reached unprecedented heights, with over 14 million units sold, reflecting a 35% increase from the previous year. This surge underscores a pivotal shift towards electrification in the automotive industry. The journey of an electric vehicle begins long before it hits the road. The manufacturing phase, particularly the production of lithium-ion batteries, is resource-intensive and contributes significantly to the vehicle's initial carbon footprint. Recent studies indicate that producing an EV can result in up to 40% more CO2 emissions compared to conventional vehicles, primarily due to the energy demands of battery manufacturing. For instance, crafting a 75 kilowatt-hour lithium-ion battery can emit between 7 to 15 tons of CO2, equating to the emissions from burning approximately 1,000 gallons of gasoline. The batteries that power EVs rely on critical minerals such as lithium, cobalt, and nickel. The extraction and processing of these materials pose significant environmental challenges and raise ethical concerns. Lithium extraction, for example, is a water-intensive process. In Chile's Atacama Desert, mining activities consume vast amounts of water, leading to the depletion of local water resources and adversely affecting indigenous communities and ecosystems. Cobalt mining, predominantly centered in the Democratic Republic of Congo, has been associated with human rights violations, including child labor and hazardous working conditions. These issues underscore the complex socio-economic dimensions of the EV supply chain. The global nature of the EV supply chain entails extensive transportation of raw materials and components, contributing to the overall carbon footprint of electric vehicles. From mining sites in remote regions to processing facilities and assembly lines across continents, the logistics involved in producing an EV add layers of environmental impact that are often overlooked. Once on the road, electric vehicles offer clear environmental advantages, notably the absence of tailpipe emissions, which contributes to improved air quality and reduced greenhouse gas emissions. Life cycle analyses reveal that, over their operational lifespan, EVs can emit up to 70% less CO2 compared to traditional vehicles, contingent upon the energy mix of the electricity grid used for charging. The environmental benefits of electric vehicles are intrinsically linked to sources of electricity that charge them. In regions where coal remains a dominant energy source, the carbon footprint of EVs can be comparable to that of efficient gasoline vehicles. Transitioning to renewable energy sources is imperative to maximize the environmental advantage of electric vehicles and achieve meaningful reductions in greenhouse gas emissions. As the first generation of electric vehicles approaches the end of its service life, the focus shifts to the recycling and disposal of batteries. Efficient recycling processes are essential to mitigate environmental hazards and recover valuable materials. Recent advancements in battery recycling, such as the development of closed-loop systems, aim to recover up to 95% of critical materials, thereby reducing the need for new mining activities and lowering the overall environmental impact. In 2024, notable collaborations emerged to enhance battery recycling capabilities. For instance, Jaguar Land Rover partnered with Altilium to test EV batteries made with recycled materials, aiming to establish a sustainable supply chain and reduce reliance on virgin materials. Such initiatives are pivotal in addressing the anticipated increase in battery waste and aligning with regulatory frameworks that mandate higher recycling rates and the incorporation of recycled content in new batteries. To reduce the environmental and ethical concerns associated with lithium-ion batteries, scientists are exploring innovative alternatives. Solid-state batteries, for instance, promise higher energy density, enhanced safety, and lower reliance on scarce resources like cobalt and lithium. In 2024, sodium-ion batteries gained traction due to their abundance and cost-effectiveness. While they currently lag behind lithium-ion batteries in terms of energy density, continuous advancements are closing this gap, making them a promising option for future EVs. The shift towards electrification extends beyond environmental implications, influencing job markets, energy policies, and global trade dynamics. EV adoption fosters job creation in renewable energy, battery production, and charging infrastructure development, while simultaneously disrupting traditional automotive and oil industries. Countries investing heavily in EV infrastructure and renewable energy sources are positioned to lead the green economy, while those reliant on fossil fuel exports face economic challenges. Despite their undeniable environmental and economic benefits, electric vehicles face several significant challenges that could slow their adoption. One of the most pressing issues is their accessibility and affordability. While the cost of EVs is steadily decreasing due to advances in battery technology and economies of scale, the upfront expense remains a formidable barrier for many potential buyers, particularly in developing regions where disposable income is limited. Even in wealthier nations, charging infrastructure disparities highlight the challenges faced by consumers in rural or underserved areas. Urban centers may enjoy the convenience of abundant charging stations, but smaller towns and remote regions often lack even basic access, creating a geographical divide that could hinder widespread EV adoption. To truly embrace the promise of electric vehicles, equitable development is essential. Governments, businesses, and communities must work together to bridge these gaps, ensuring that the transition to sustainable mobility is inclusive and accessible to all. Governments worldwide are stepping up their efforts to promote electric vehicle adoption, recognizing the role EVs play in combating climate change. Policies such as subsidies for EV purchases, tax incentives, and the implementation of stricter emissions regulations are becoming increasingly common. In fact, by 2024, over 25 countries pledged to phase out the sale of internal combustion engine vehicles entirely by 2035. These commitments are not just lofty ambitions. They represent a unified global effort to reduce greenhouse gas emissions and transition to a greener economy. While these regulatory measures are crucial, their success will depend on the alignment of global cooperation, private sector innovation, and public acceptance. Together, these forces can catalyze a transformation in transportation unlike anything we've seen before. Electric vehicles represent a groundbreaking shift in transportation, but are they the ultimate solution to our environmental challenges? Experts caution against viewing EVs as a silver bullet. Instead, they must be part of a larger, more comprehensive strategy to achieve sustainability. Investing in improved public transportation systems, encouraging active transportation like walking and cycling, and rethinking urban planning to minimize car dependency are equally vital steps. Electric vehicles alone cannot address issues like traffic congestion, urban sprawl, or the environmental toll of mass production. The true power of electric vehicles lies in their ability to complement broader efforts toward decarbonizing transportation and creating more livable, sustainable cities. By integrating EVs with renewable energy sources, fostering advancements in battery recycling, and embracing a multimodal approach to mobility, we can unlock their full potential. The journey toward sustainability is a long and complex one. Electric vehicles mark a critical milestone on this path, but they are just one piece of the puzzle. By addressing the environmental and ethical issues within the EV lifecycle, fostering equitable global adoption, and reimagining transportation systems, we can create a future that is not only greener, but also fairer and more resilient.